Okay, thank you so much. Thanks for being here. I know it has been quite a long day. So I'm gonna talk to you a little bit about the monarch butterfly. And I know most of you perhaps have already heard that the monarch population has been going down over the last couple of decades. And even though there are strong hypotheses behind explaining that that decline, and the monarch is one of the most well-researched insects out there, there are still several questions yet to be answered. As a response to that, I'm going to be presenting you with a part of my PhD dissertation that is a novel modeling approach to understand the monarch's migration. And then I will feature its potential by answering one single question. Where do we have to provide more habitat for the monarch? So first, a little bit about the migration. This is a spectacle of the monarch. The monarch starts its migration, let's say in Mexico, where it overwinters from November to March, in some very specific patches of forests. When spring comes, those monarchs mate, and they start their migration north and start laying their eggs across the Mexican-US border on top of this plant, milkweed. Now, keep in mind, the fate of the monarch is tightly bound to the fate of this plant because it is the only plant that the monarch can use to lay its eggs. Now, those eggs eventually will mature, turn into adults, and keep dispersing across the eastern US and reaching up Canada across several generations. Now, this will take about 5 generations, and that 5th generation that is bred around this time actually, that generation will trigger a migratory behavior back south to the same overwintering sites that their great-great-great-grandparents overwintered a year before. So as you can imagine, that is quite impressive. What you can see here, this forest, that brownish color that is covering the trees, those are monarchs. So having that amazing concentration of individuals in just one single space, it's quite convenient to give an estimation of the population. So WWF in Mexico, they do that. They measure the area of the colonies and give an estimation every year. They have been doing that for the last 2 decades or so. And so giving us this graph. So as you can see, there is a downward trend. We hit rock bottom on the 2013-2014 season. Since then, it has improved a little bit, at least stabilized, but we are still in a critical condition, especially considering the oscillating pattern of this species. Now, there are strong hypotheses that describe what is happening behind that. The main one is the milkweed limiting hypothesis. That one says that the increase of genetically modified crops across the US and Canada, along with herbicides specific for those crops, has practically wiped out milkweed and leaving the monarch without a breeding habitat. So as a response to that, there are several efforts right now in place trying to bring back a little bit of that habitat. This is just one example. These are the Monarch Equistation program, which is small areas that people give to provide monarch-friendly habitat. But as you can see, there is a strong concentration of those way stations in what is called the Corn Belt, the Midwest. And this is just the example of the Monarch Equistation program, but most of the efforts are actually focused on that area. So the question is why? Why are they doing that? Well, the main answer and the main reason for that is that most of the monarchs found at the overwintering sites, they come from those areas. Doing radioisotopes, it has been found that they come from those areas. However, we are arguing that that is not enough reason for us for focusing the efforts there, because in the end, the monarchs that went to overwinter, their parents came from somewhere else, and so on and so forth. So maybe that is not the best place, the best solution. So that brings us to our research questions. So the first one is, for which of the 3 regions, the southern breeding region, the central, or the north, the monarch's population is most sensitive to a change in milkweed availability? So that is the first one. And the second, what would be the ideal distribution of milkweed improvement efforts across those 3 regions to achieve a minimum viable population? So those are our 2 guiding questions. Now, what we are using to answer that is a method called system dynamics modeling. It's a modeling technique. And this is the most simple example of that technique. It's a predator-prey interaction, and it is a graphic approach. So it's really easy to visualize feedback loops which are based on system theory. So we are looking for causal loops for feedback behavior within the system, and that allows us to incorporate a lot of unknowns, which sometimes is really difficult in normal modeling techniques. Just for you to know, under the hood, the way this modeling technique, what it is a system of partial differential equations. Okay, so our model, so you already saw this little animation. Well, we are turning that into a systems model, dynamics model. We have an overwintering system, a migration system, and then we divided the breeding areas in three: the southern, central, and north, that emulate the life cycle of the monarch and allows a dispersal across those areas. We have drivers behind that drive this model, such as soil moisture, temperature, milkweed availability, development time, interbatch distance, compensatory effects, and climate change. So all of that is driving the stochasticity within the system. And what actually is important about this approach, what I was telling you, is including unknowns, is that all of those underlying elements have never been actually included in modeling efforts so far for the monarch, because there is not a lot of information about them. So I'm gonna give you just one example of how we are including it, and that is the relationship between soil moisture, temperature, and milkweed availability. So it is obvious, we know, that if there is a drought, we will have less stems across the landscape. It's obvious, if we have more rain, maybe we will have more. However, most models so far, they consider just a steady number of milkweed, regardless of the weather. So that is kind of a strong drawback. But they are not including this dynamic behavior, because so far there is no research telling us that relationship between soil moisture, temperature, and milkweed availability. So through optimization, we built this 3D shape. So we optimized for a better fit of the model. And that 3D shape tells us that at 24 Celsius, 40% of soil moisture, we will have a top availability of milkweed. If we deviate from that ideal, the number of stems across the landscape will decrease. So that is just one example of how we are including those unknowns. Now, another thing that makes this model different from previous efforts is that previously we consider models have been said had considered, let's say, an egg will hatch in 5 days. That's it. But we know that that is not true. Insects, butterflies especially, they don't need days to develop. They need temperature. So actually, what we need to include is day degrees. So we turn that into day degrees, which is related with the weather that our model is generating. I'm gonna give you an example of the relevance of this. So what you can see here in this graph, this is days to overcome one stage, one developmental stage. We have egg, larvae, pupae, adult, and the sum of the whole stages, so the total lifespan of the monarch. And here we have the temperature. So when it is really cold, as you can see, it takes forever for a monarch to develop. But if we start increasing the temperature, you can see how dramatically the intergenerational time decreases. So it's really important to take into account the temperature, especially now with climate change, in order to get an accurate model. So we are including that, and it is giving us some really neat results. For example, this is the main output of our model, okay? So it's a stochastic model, so we use 1,000 of these simulations to get stochasticity and confidence intervals and to do the rest of our analysis. What you can see, this yellowish bars, that's the observed data, and what is moving is actually the data that we are getting from the model. We have analyzed the output, the performance of the model with several metrics. I'm just going to show you one. The top panel is the simulated values, what we get, and these three are independent data sets of relative abundance. So as you can see, the behavior of the curves is pretty similar. In this case, for example, relative abundance in the south. In the 4 cases, the curve is bimodal at the beginning of the season and in the end, and they tend to have a similar behavior. Of course, it's not going to be the same, because the methods are different. Most of these are done by citizen science, but the behavior of the curve is similar. We can see the same with the central part of the breeding regions and the north. I can go back to this during the Q&A if you want. Okay, but going straight to the research question, answering our research questions. So the first one was sensitivity to change in milkweed. So the efforts right now are focusing in the Midwest, in the central part. As you can see here, central is not the one that would give us more bang for our buck. The one that actually is having more effect is the southern part. There are, of course, a lot of interactions, but as you can see, actually the north is null. So the efforts in Canada, of course, being the extreme of the range, is not that significant in comparison with the mid part of the range. Now, using that information, we can answer the second question, sensitivity to milkweed. What is the optimal configuration of a management program to provide more habitat? So the way we did this is that we run 5,000 simulations with known values, like a baseline until 2019, until today. And from there, we change the percentage of availability randomly and try to optimize to get 20 years from now an average of 6 hectares minimum, which is what it is being recommended. So this is what we get. So if it is the baseline, then we let it go. In order to get this is then the optimal solution. What we are recommending is an increase of 304% milkweed in the south, 132.9 in the central part, and 166.6 in the northern region. So just keep in mind, this is still in development, so this is not the final number, but at least this is what we are, where we are right now. So finally, for conclusions, most of the times in my talks, I don't give conclusions. I rather open the floor so you guys can give me your conclusions and your questions about what you just seen. So with this, thank you so much. Thanks.
Rodrigo,
Yeah.
so you guys are suggesting your preliminary results to increase by 300% roughly. Like, do you have any ideas how that could be achieved? Like any suggestions?
Well, there are several suggestions, especially speaking about the south. There's a lot of ranching, so there's a lot of open range that can be used for that. But also, it's already being put in place a little bit. Side roads, railroads, those are really good places where habitat can be placed. Yeah.
Do you think that, or would increasing the amount of milkweed in those areas have any effect on the surrounding organisms or vegetation?
I mean, of course it would. First, mostly would be beneficial for pollinator species that share the same habitat. And besides, any negative effect that you could see, in the end would be going back to the baseline, right? But we are not analyzing who would be affected right now.
Is the land area in the south that you're talking about, is it much smaller than the land area in the north area?
It's basically the same.
If milkweed is affected, like if its populations are affected so heavily by glyphosate, is there any evidence for glyphosate resistance developing in milkweed?
Not in milkweed right now. Well, not Asclepias syriaca, which is the specific milkweed. There are some other Asclepias species that are starting to show a little bit, and other herbs that are totally resistant right now. So who knows in the future? Yeah.
Do you have any idea what, so in the south, in that 300% range, do you have any idea what a pre-colonial or close to that level would be for milkweed? Like is that above a number that is potentially expected under a somewhat natural environment?
You know, it actually just like 6 months ago, one paper was published with that, looking at the museum records and stuff like that. To be honest, I don't have the number. I can get you back on that.
We're just trying to understand the energetics. So those adults that are flying back from the north, they return to Mexico, they overwinter, and then they leave the overwintering site and fly back north.
Yeah.
What period of time is involved that they have to maintain their reserves? Like how far north do they have to go in the spring before they start the first generation again?
Well, that varies a lot. Like the southern part of that range would be like the Mexican-US border, but the overwinter individuals have been found all the way up to Minnesota.
Is there a resident population if you're wintering?
There are resident populations, yes. They don't tend to interbreed, they do, but they don't tend to do it. But that is actually one of the other problems, and that's why I try to always be a bit careful in the way I speak, and because there's the problem that people did provide milkweed to Monarch, but not native milkweed. And there is this tropical milkweed that actually captures the migrants, and they are happy all year round, so they stop migrating. So yeah.
I think we'll probably have to leave it there, but.
Thank you so much.